One quick way to test your understanding of integer handling in C is of course by testing yourself. And that is what we are going to do in this video. I went ahead and Googled about it and found an interesting and quite famous quiz online. First few questions were obvious, but rest of them were very good. Instead of going through all the questions in the quiz one after another, I took two questions and decided to bisect them in this video. These questions are number 3 and number 4. Rest of the quiz I would recommend you to try later. Let's go to the whiteboard and discuss question 3 first and follow it by question 4. So we have a C expression here and we want to find what it would evaluate to. Obviously on the left hand side, the operand has been casted to unsigned short. On the right hand side, we have just -1. So obviously the -1 will have signed integer type because that's the default type for a constant in a C program. This one is unsigned short and this one is signed integer. So the first thing which will happen obviously here is that because unsigned short is lower than integer, so integer promotion rules will come into play obviously. Now on most of the common modern C implementations, unsigned short is 2 bytes in size and signed integer is 4 bytes in size. So obviously all the unsigned values, unsigned short values can be represented in a signed integer because it's higher in size. In integer promotion, this would be converted to integer and this would remain as it is, -1. So obviously the expression would evaluate to 1. That is true. But there is a corner case here. There could be implementations where even integer size is 2 bytes. Now this is a tricky case. Say if integer on an implementation is 2 bytes, then obviously the range of values it can have, if we plot a number line and this is 0 and this is the maximum value an signed integer can have, and that value is, if it is 2 bytes, so it would be 2 raised to power 15 minus 1. And the lowest value would be minus 2 raised to power 15. Unsigned short on the same implementation is 2 bytes. So the range of values it will have would be far higher on the positive side. It would be somewhat around 2 raised to power 16 minus 1. So there is this range of values here which can't be represented if the signed integer is 2 bytes. So obviously if we promote, we apply integer promotions obviously, but then if we apply integer promotions and convert unsigned short to int, we won't be able to represent all values. But what the C standard says here is that then we should upgrade the values to unsigned integer. So in this case, if we upgrade to unsigned integer, all the values of unsigned short would obviously be representable in unsigned integer. So in that case, what would happen is 1 will remain 1, but -1, the bit pattern of -1 is all ones. So it is F, F. So bit pattern is essentially all the bits are 1, 1, 1, 16 ones. And 16 ones, if you convert to an unsigned value, this value is quite huge. The hex would be, and if you can also write it as, so obviously if you evaluate this would be 0. We have another C expression here and we want to evaluate it. The first thing obviously we want to clarify here is this is -1L, and L stands for long here. So this -1 has data type long, and long would be obviously signed long. This one has unsigned here, so the type would be unsigned int. Now if we want to evaluate this, we want to first find the type of the operands. So the left operand obviously has signed long. On the right side, it is unsigned int. Now unsigned int on a typical Linux or Unix based C implementations, unsigned int on a 64-bit or 32-bit is always 4 bytes. But long, on the other hand, has different size on different implementations or a combination of operating system and compilers. So for example, on Linux or Unix based 64-bit operating system, long is 8 bytes. But on 32-bit operating system, it is 4 bytes. Even on Windows, with some of the compilers, for example, even Microsoft Visual Studio compiler, long is 4 bytes. But with some other compilers, even on Windows, it can be 8 bytes. So the behavior would obviously be implementation defined here. Let's see what promotions are applied here. So before we can evaluate this, we need to apply C standard promotions and possibly usual arithmetic conversions. Now promotions, the default integer promotions won't apply here because both the data types are bigger than or equal to integer. Now let's see which one is bigger here. So in case the long has size 4 bytes, that is maybe 32-bit Intel with Linux or Microsoft Windows Visual Studio compiler, it would be 4 bytes. In that case, the size is equal. So, but then this is unsigned int and this is signed long. Obviously, not all the values of unsigned int can be represented in signed long. So both of these would be upgraded to unsigned long. So this one would remain as it is, and this one would go to an unsigned value, a very big value, because -1, the bit pattern is all ones, as we just discussed. So this would obviously evaluate to true. But if the long has size 8, then obviously all the values of unsigned integer, which is just 4 bytes, can be stored in this type. So in this case, this operand will keep its type. So it would be signed long, -1, and this one would be 1. So obviously this is false. So depending on implementation, this expression will either evaluate to false or true. If you go back to the Google search I showed you earlier, we did found an interesting discussion online about the quiz. I would highly recommend you to read it after going through the quiz. Links are in the description. And thanks to the author John Regehr, who had originally written the quiz, this quiz does take certain assumptions about environments and it does list them, but few of the things it assumes but doesn't list. And some of the questions have wrong answers, but nonetheless, it's a good resource for learning integer handling in C. Rest of the quiz I would like you to try out later. If you are interested to know more about integer arithmetic conversions in C, feel free to watch my other video on the same topic. Thank you very much.